This video will give you a brief review of the periodic trends that we're going to be discussing in this course. So there are four major trends. They all are based in the same reasoning, which we'll talk about together in class. So for now, I just want to get you kind of the definitions and which way the trends tend to go. So first up is what's known as first ionization energy. So this is the amount of energy it takes to remove an electron from a neutrally charged atom. So that means we're starting from something with a charge of 0, and we're producing a +1 cation and a single electron. And that ionization energy is the amount of energy it takes for that process to happen. Essentially, it is the delta H for that reaction. So if we're looking at our periodic table, ionization energy tends to be lowest down in the bottom left-hand corner and highest up in the top right corner. So vertically, it's higher at the top, lower at the bottom. So it increases going up here. And then it is lower on the left and higher at the right. So note that these are all trends. They're not perfect. There are examples that go against the trend where something farther to the left might be higher. But if I'm asking you without any additional data, which of these has the higher ionization energy, I would assume that you would go with the trend. So note that for ionization energy, a low value means that it's easy to remove an electron. So it's really easy for the electrons down in these elements to be removed, which is part of why they tend to be very reactive. We know that the alkali metals react rather violently with water, and that is because it's so easy to strip an electron away from them, because they all have such low ionization energy. Since they're all the way to the left of the periodic table, they react very easily with a lot of things. So low ionization energy means it is easy to remove that electron. High ionization energy means it is very hard to remove that electron. Our next trend is kind of the opposite, is adding an electron, which is known as electron affinity. So this is the energy that's transferred to add an electron to a neutral atom. So we're starting with something with a 0 charge, adding an electron onto it, which means that we're producing a -1 charged anion here. Now the trend goes in the same direction. Low values in the bottom left, high values in the top right. But the meaning is kind of opposite. For ionization energy, low means easy and high means hard. For electron affinity, it's the other way around, unfortunately. A low electron affinity means it is difficult to add an electron to that atom. If you think about the names of the things that can help, that ionization energy is an amount of energy that you have to put in to make this happen. So a high ionization energy means you need to put in a large amount of energy. It is difficult to do. The word affinity means, how much you like something. Or how good you are at something. So this is looking at, does this atom have an affinity for electrons? Does it want electrons? If you have a high affinity for something, that means you like it or you're good at it or you want it. If an atom has a high affinity for electrons, that means it's going to be really easy to add an extra electron into it. If it has a low affinity for electrons, not so easy. So the trends go in the same direction, which is kind of convenient, but you have to remember that the meanings are opposite. Also note that the noble gases are kind of excluded from this trend because they don't really bond to things very much, so it doesn't quite apply to them in the same way. Electronegativity is our next one, which is commonly confused for electron affinity because their names are so similar. Electronegativity only applies to atoms in bonds, so it's a little bit different. For electron affinity, we're just shoving an extra electron into an atom by itself. Electronegativity, words are hard, is how strongly an atom attracts electrons once it's already involved in a bond. Is it pulling those electrons towards itself more or less? So a low electronegativity means it doesn't really pull on the electrons very much. A high electronegativity means that it's trying to win the tug of war and is really yanking on those electrons, pulling them towards its end of the bond. Again, the trend goes in the same direction, that we have low electronegativity in the bottom left, high in the top right. Specifically, fluorine is the very highest of all of the elements. Once again, noble gases are excluded here because they don't really bond the way that most other elements do. So most of them do not have a calculated electronegativity value because we don't have enough compounds containing them to get the data that we need to figure that out. And then last but not least is atomic radius, which is pretty much exactly what it sounds like. It is the radius of an atom. It is technically defined as half the distance between two bonded nuclei. So if you have two atoms of the same element bonded together by a single covalent bond, so they're connected here by a covalent bond, they have their orbitals that are overlapping. Whatever half the distance between those two nuclei is the technical definition of atomic radius. And this is one where the trend goes in the opposite direction. Our smaller atoms are in the top right corner, our larger atoms are in the bottom left corner.